This is a distribution of the sample mean, also known as central limit theorem. It's the main theme of this section. And some review of some symbols. X is equal to random. I'm watching one of those evolution movies on sci-fi. X equals a random variable, mu is equal to mean, sigma is equal to standard deviation. Now, distribution of the sample means will approach a normal distribution. The mean of the sample means will approach population mean, and standard deviation of the sample means will approach a population standard deviation, divided by the square root of the sample size. Instead of looking at like one individual, or one book, or one student, or whatever we're studying, we'll be taking a look at like 20 individuals, and we'll be taking the average age or average number of pages or whatever we're taking a look at. So that's what they're talking about with the sample means. They give an example in a book, I think, where you go out there and you sample 20 people, find their average. You go out and sample another group, find their average, and so forth. For samples of size n larger than 30, the distribution of the sample mean can be approximated by a normal distribution if the original data is fairly close to normal. And if the original population is normally distributed, then any sample size will work, within reason. One wouldn't be enough, of course. Now, some formulas we're going to use to do it by hand are these right here. We got mu sub x bar, that's equal to mu, and sigma sub x bar is equal to sigma divided by square root of n. Now that's mu of the sample means, the sigma of the sample means. And the z will equal to x bar minus mu sub x bar over sigma sub x bar. Let's take a look at just finding a couple of those. Okay, so mu is equal to 40, and sigma is equal to 5, and n is equal to 20. It says determine mu sub x bar, so the mean, the mu of the sample means, and sigma sub x bar. Well, this one's boring. The mean of the sample means will just be the population mean. So that's 40. And where I'm getting that from is the previous slide right there. This one's a little bit more exciting. To find the standard deviation of the sample means, we're going to take the standard deviation divided by the square root of n, which will be 5 over the square root of 20, which gives us 5 divided by second x squared, 20. I'll take it 2 decimal places, 1.12. Now, central limit theorem. Regardless of the shape of the underlying population, the sampling distribution of x bar for sample means becomes approximately normal as the sample size n increases. This is saying that it may not be a normal distribution to begin with, but when you start taking about the averaging together values, then it as your n increases, then it does become approximately normal. Now that's kind of meaningful, because that's when you're talking about you don't know what the data is, or it's skewed left, skewed right. That means if you take enough of them, then it will follow a normal distribution. Now here's how we're going to do it on the calculator. Normal CDF, lower bound, upper bound, mean, and sigma divided by square root of n. So it's not tough to do these on the calculator. We'll also do them by hand. Let's look at our first problem. Test grades are normally distributed with a mean of 70. So mu is equal to 70, and standard deviation of 2. So sigma is 2. Now A says, what is the probability of picking a test grade out and getting one less than 69? Okay. So we're talking about 1 here. See, picking a test grade out and getting one less than 69. Well, here's 69, less than. It'll be shaded this way. Now I'm going to do this in a calculator first. Clear over here, again, is negative infinity, or negative E99. So to do this on our calculator, we'll do normal CDF, abbreviated that way. We'll put negative E99, comma, 69, comma, our mean, which is 70, comma, our standard deviation, which is 2. Now, since we're talking about 1 test grade, we don't need to do the this right here. This is what we did before. So let's see what that gives us. Normal CDF. So I do second vars, normal CDF, negative E99, so second comma, 99, comma 69, comma 70, comma 2, and enter. And I'll take this 4 decimal places. We got 0.3085. Well, let me do it by hand, using tables and so forth. So that's calculator. Now let's look at by hand. Well, this is an x value. This x equals 69, so we need to convert it to a z-score. So we got z is equal to x minus mu over sigma. So we got z is equal to x, which is 69, minus 70 over 2, or z is equal to negative 1/2, or negative 0.5. Now our picture now looks like this. We got z is equal to negative 0.5, and we're shading to the left, which is perfect for our tables because it's based upon area of the left. So let's go look at our tables. Now that's really like negative 0.50, so our hundreds place is zeros. So we're looking in our first column here, so that's where the hundreds place is 0. And we're looking up negative 0.5. Negative 0.5 is right down here, so we get 0.3085, which is what we got with the calculator there. Okay, now that's nothing new. That's what we did back when the normal distributions. Let's look at the part B though. What is probability that a random sample of 8 test grades have a mean less than 69? Okay, less than 69, still shaded to the left. So we're going to do normal CDF, negative E99, comma, 69, comma our mean, which is 70, comma our standard deviation divided by the square root of n. And since we're talking about 8 test grades, we'll put 8 there. Now, the reason why we're doing that is it's more than 1. See how it's 8 test grades? That's when you use this formula right here. So this is when you got more than 1. Now let's put this in the calculator. I'll do second vars, normal CDF, negative E, so second comma, 99, comma, 69, comma, 70, comma, 2, divided by second x squared for the square root of 8. And that gives us 0.0786. Okay, that's via the calculator. If you understand the previous normal applications, this is very easy. You just take your standard deviation divided by the square root of n. So it doesn't change a whole lot. Now by hand. Remember, this is x, so we need to change it to a z-score. And we do x minus mu sub x bar over sigma sub x bar. Well, the mu sub x bar is equal to mu, which is 70. Sigma sub x bar is equal to sigma divided by a square root of n. Well, sigma is 2 divided by the square root of n, which is that. Let's see what that gives us. So 2 divided by second x squared, 8, enter. 0.707, 106, 78, 12. You don't want to do rounding on these, not until the appropriate time. So we're going to plug all that in. So this formula, we got z equals x, which is 69, minus mu sub x, which is 70, divided by sigma sub, or I guess mu sub x bar, sorry, sigma sub x bar, which is 0.707, 106, 78, 12. Okay, so if I plug this in my calculator, I have to be sure to put parentheses around top. So I do beginning parentheses 69 minus 70, closing parentheses, divided by. Now I could type all that number in, but since that's my previous answer, all I have to do is do a second and then my negative, and that'll bring up a and s, which is the previous answer, and then enter. Now we want to round this to 2 decimal places since we're looking it up in our tables. So we got negative 1.41. Now our picture looks like this. We got negative 1.41 and we're still shading to the left, just like the picture right here. Okay, so let's look it up in our tables. Now the hundredths place is the 1, so I'm going to look in the 0.01 column. And I'm looking up for negative 1.4. So I go down to negative 1.4, and I get 0.0793. Notice, it's a different answer than what I got up above. It's close, but it's different. Again, unfortunately, when we use tables in the book, we have to do some rounding, and we lose some precision. The calculator gives you a more accurate answer. Let me save this. What is this? Distribution of sample means. .pdf. There we go. And ready for part C on that problem. There we go. Still on 2. This is part C now. And our mean is still 70 from up above. And our standard deviation is still 2. Now C. What is probably a random sample of 15 test grades have a mean less than 69? Well, the picture is still this way, less than 69, looks like that. So we'll do our normal CDF, negative E99, comma, 69, comma, our mean, which is 70, comma, our standard deviation divided by the square root of n. And here we're talking about 15 test grades. Now again, you use this formula right here when you got more than one. In this case, I'm taking a look at 15 test grades and average them. So let's see what that gives us. So second vars, choose normal CDF, negative E99, comma, 69, comma, 70, comma, 2 divided by square root of 15. Enter. And we get 0.0264. That's via the calculator. Let's look at it by hand. Still the same picture. Like that. And we need to change it to a z-score. Z is equal to x minus mu sub x bar over sigma sub x bar. So I need mu sub x bar. Well, mu sub x bar is equal to mu. So that's equal to 70. Sigma sub x bar is equal to sigma divided by square root of n. So we're going to have sigma, which is 2, divided by the square root of 15. So 2 divided by second x squared, 15, enter. And we get 0.51639 3/7 95. So x is 69 minus mu sub x bar, which is 70, over all of that. Again, I don't want to round until I absolutely have to, like when we're getting ready to look it up in the table. Again, the key to putting these in your calculator is put parentheses around the top, because we got more than a single number up there. So I'll do beginning parentheses 69 minus 70, closing parentheses divided by, and this number here is my previous answer, so again I can do a second negative to bring up the previous answer. Then enter. And I'll take this 2 decimal places. We've got negative 1.94. Negative 1.94. Okay, our hundredths place is the 4. So we're going to be looking in this column. And negative 1.9. So we get 0.0262. And we take that directly because that's the area of the left, which is what we're looking for. And you see, we compare it, and it's fairly close. Let's take a look at the next problem. Number 3. It says test grades are normally distributed with a mean of 70. So mean is 70, and standard deviation of 2. Okay. A. What is the probability of picking a test grade out and getting one more than 69? That's 69 over here? Yeah, it is 69, isn't it? Oh well. It doesn't matter what number. I'm just showing it. Okay. More than 69. So we've got 69 here. Of course, we know from the fact if all this adds up to 100%, we could take 1 minus our previous answer and get it. But that's not the goal here. I'm trying to show you the setup. Okay, so we're talking about a test grade, which means we'll just do our direct normal CDF. So do 69, comma, E99. Since it's shaded clear to the right, that's where we go to E99, positive infinity. Comma our mean, and comma our standard deviation. We don't have to divide by square root of anything because it's a single item. A single test grade. So let's see what that gives us. Second vars, normal CDF, 69, comma, second comma, 99, comma, 70, comma 2, and enter. And we get 0.6915. Like that. Okay, that's via the calculator. Let's look at by hand. We need to convert it to a z-score. So we got z is equal to x minus mu over sigma. X is 69 minus mu, which is 70, divided by sigma, which is 2, which gives us negative 1 over 2, which gives us negative 0.5. So our picture now looks like this. We got z is equal to negative 0.5, shaded to the right. Well, our table on the back of the book only works if it's shaded, if it's to the left, the area to the left. So we have to do 1 minus z is equal to negative 0.5, the area to the left. Because if we subtract off the area to the left, that'll leave us the area to the right. Because remember, 1 is everything. So let's go look this up in our table. Now that's really negative 0.50, so our hundredths place is a 0. So we're looking in the hundredths place of 0, this column. And negative 0.5. Negative 0.5 is down here, 0.3085. So 1 minus that, let's see what that gives us. 1 minus 0.3085, enter. And we get 0.6915. Oh, that's bizarre. Matched exactly that time. Of course, I guess I didn't do any kind of rounding here, did I? Let me save that. And let's take a look at our next part. We'll do part B. So this is 3B. Okay, our mean is still 70. Our standard deviation is still 2. And B says, what is probably a random sample of 10 test grades have a mean more than 69? Okay, so still 69, more than shaded that way. So we'll do our normal CDF, our lower bound, which is 69, our upper bound, which is E99, or positive infinity, since it's shaded to the right. Our mean, which is 70, and then we take our standard deviation, divide by the square root of n. Here we're talking about 10 test grades, so I divide by square root of 10. So we got second vars, normal CDF, 69, comma, second comma, 99, comma, 70, comma, 2 divided by the square root of 10. Enter. And 4 decimal places, so we'll get 0.9431. And let me shift to position here a little bit. Sitting too long today. Okay, so that's my calculator. Let's look at by hand. We need to change it to a z-score, and that's going to be x minus mu sub x bar over sigma sub x bar. And mu sub x bar is equal to mu, so that's equal to 70. Sigma sub x bar is equal to sigma divided by a square root of n. And sigma's 2, and square root of n is, what is n? 10. So let's see what that gives us. 2 divided by the square root of 10. And we get 0.6324 3/5 3/2. So this becomes x, which is 69, minus mu sub x bar, which is 70, over sigma sub x bar, which is 0.6324 55532. And again, if we're going to put the top in our calculator, we have to put parentheses around it. So we got beginning parentheses 69 minus 70, closing parentheses divided by our previous number, which again I can do second negative for the answer, inner. Then we get negative 1.58. Okay, so our picture, here's negative 1.58, and this is a z-score now. And I think we're shaded to the right, yeah. So we're still shading to the right, which doesn't work out well with the book. So we're going to rewrite it as 1 minus z is equal to negative 1.58, shade to the left. Which now we can look it up in our tables. Because again, tables is based upon the area of the left. So let's go look it up. The hundreds place is the 8, so I'm looking in the 0.08 column. And then the first two is negative 1.5. Negative 1.5 in the 8th column, I get 0.0571. So let's subtract those. 1 minus 0.0571, enter. And we get 0.9429 by hand. See how that compares. 0.9429, 0.9431. Again, they won't be the same. The calculator is more accurate. Though, does it really matter? If I told you there's a 94.31% chance versus a 94.29% chance, is that really about the same? Yeah. I'm not sure if I have room for the... What part was that? That's part B. Yeah, I don't think I have room for C. So let me save this. And let's look at part C. Okay. So 3C. Our mean is still 70. Standard deviation is still 2. And C says, what is probably a random sample of 20 test grades have a mean more than 69? So here's 69, more than is still shaded this way. So we'll do normal CDF. And then 69 is our lower bound. E99 is our upper bound. Our mean, which is 70, and our standard deviation, which is 2, divided by the square root of n. And here we're talking about 20 test grades, so I'll put 20 in there. Okay, so I'm going to do second vars, choose normal CDF. 69, comma, second comma, 99 for E99, comma, 70, comma, 2 divided by the square root of 20. And we get 0.9873. And that's via the calculator. And let's look at it by hand. We want to switch it to a z-score. So z is going to equal to x minus mu sub x bar over sigma sub x bar. Mu sub x bar is equal to mu, which is equal to 70. And sigma sub x bar is equal to sigma divided by the square root of n, which is 2 divided by the square root of 20, since we're talking about 20 in part C. So we got 2 divided by square root of 20. And we got 0.44721 35 955. So we'll plug all those into our formula here. X is 69 minus 70 over 0.44721 35955, which gives us 69 minus 70, closing parentheses, divided by the previous answer, so second divide, enter, negative 2.24. Rounded to 2 decimal places. And our picture now looks like this is z is equal to negative 2.24, and I'm shading to the right, which isn't good. Table is based upon the area to the left, so I have to rewrite this as 1 minus z is equal to negative 2.24, so shaded to the left. When it's always shaded to the right like that, you always rewrite it this way for the table. So that's nothing new. Now here are hundreds places of 4. So we're going to look in the 0.04 column for the hundreds. And negative 2.2. Well, negative 2.2, we get 0.0125. Now I'd say the probability is pretty high. My eye is going to get off on one of these problems, and one of these numbers will be wrong, but I think you get the idea. 1 minus 0.0125. Enter. And we get 0.9875. .9873, 0.9875, so that shows you the difference between them. Let me save that. And then let's look at our next problem. Number 4. Okay, we've done the less than, we just did the greater than. Number 4 is the third type, between. These encompass all 3 different types that you'll run across in these problems. So let's look at A. Let's see, mean is 70, standard deviation is still 2. And was probably picking a test grade out, one test, and getting one between 60 and 71. So here's 60 and here's 71. Between, of course, is shading in between them. So this is normal CDF, 60, 71, 70, and 2. We don't have to do any kind of dividing by the square root of n, because there's only one. We're talking about one test. So let's see what that gives us. Second vars, normal CDF, 60, comma, 71, comma, 70, comma, 2, enter. And we get 0.6915. And this is by calculator. And let's show by hand. Since it's one value, then we just go to our normal z-score. Z is equal to x minus mu over sigma. X is, actually we got 2 x values, don't we? It's getting late. Better go to bed. Okay, x equals 60 and x equals 71. We have to convert both of them. So we got x, which is 60, minus mu, which is 70, divided by 2. And on this one, we have x, which is 71, minus mu, which is 70, divided by 2. 60 minus 70 is negative 10. Negative 10 divided by 2 is negative 5. Which I'm sure is not on our table. 71 minus 70 is 1, so we got 1/2, which gives us 0.5. So our picture now looks like, here's z is equal to negative 5, and here's z is equal to 0.5, and we're shading in between. Now our table's in the back, again, based upon the area to the left, so we have to rewrite this. You take your rightmost value, z is equal to 0.5, and that goes first, and that's the area to the left, minus our leftmost value, which is z is equal to negative 5, and I'm shading to the left. Well, let's go look these up now. Okay, well, of course this is these right here. Our hundreds place here is a 0, so we're looking at this first column. And 0.5, I need to go to the next page. So looking here, 0.5, this is 0.6915. Minus negative 5, that's the previous page. Guessing it doesn't go to negative 5, it doesn't. So I go to my smallest value, which is negative 3.49, which is right here. So I'll subtract off 0.0002, which gives us 0.6913. 0.6913. Not too far off. Let me save that. And let's look at our next problem. Our next part, B. What number is this? 4. 4B. Okay, so our mean is still 70. Standard deviation is still 2. That hasn't changed. B says, what is probably a random sample of 10 test grades have a mean between 60 and 71? So here's 60 and here's 71 in between. So we'll do our normal CDF, our lower bound, which is 60, our upper bound, which is 71, our mean, which is 70, and then the standard deviation divided by the square root of n. And we're talking about 10 test grades, so I put a 10 in there. So do second bars, normal CDF, 60, comma, 71, comma, 70, comma, 2 divided by square root, so second x squared, of 10. Enter. And I'll take it to 4 decimal places, so we got 0.9431, 9431, 9431, yeah. And that's calculator. Let's look at it by hand. Of course, you need to find the z-score, and since we're talking about more than one, you have to use this formula, x minus mu sub x bar over sigma sub x bar. And mu sub x bar is equal to mu, which is 70, and sigma sub x bar is equal to sigma divided by square root of n, which is 2 divided by the square root of 10. 2 divided by the square root of 10, which is 0.632432. And we have two x values to switch here. So I got x equals 60, and x is equal to 71. So we're going to have 60 minus mu sub x bar, which is 70, over 0.6324555532. And this one will be 71 minus 70 over 0.63245532. Now, since I'm going to have to use that 0.6324 a couple different places, what I'm going to do over here is I'm actually going to store this off. So I'll press my store button, and I'll push the X key to store it in the X value. Okay, so let's find our first one here. So we got 60 minus 70. By the way, I can't do that in my head. I just want to make sure everybody knows where everything's coming from. And then I'll push the X. Because in the X, we put in that 0.6324 and a bunch of all those. And then enter. Wow. Negative 15.81. Pretty sure that's not going to be on our table. Let's look at the last one, the other one. 71 minus 70 is 1, of course, but let me put it in there. 71 minus 70 divided by x. 1.58. That looks like something more on the table. Now realize what we're looking at picture-wise. Here's negative 15.81, and here's 1.58. And there are z-scores, so there's z equals. Well, our table's based upon the area to the left, so again, I'm going to put in the 1.58 first, minus, and then the negative 15.81. That's the way it always goes. Whatever's on the right here always goes here. Whatever's on the left goes here. Kind of flip-flops. Well, let's look up 1.58. Now, the 8 is in my hundreds, so I'm going to look in the 0.08 column. 1.5, and there, 1.5, 0.9429. I've been working too much today, I think. And then negative 15.81. Well, here's negative 3.49. That's my smallest value in my table, so I'll use that one. So this will be 0.0002. Subtract those, and I get 0.9427. 9427. 9431. Not close. So let me save that. And we'll look at part C. Okay, part C. Made a stupid mistake. I went and got a pop. Drank a little bit too much here. Call of Nature's it's raining pretty loud, but I will finish. Let's see, mean is 70, sigma is 2. And C, what is probably a random sample of 20 test grades have a mean between 60 and 71? So I got 60 here and 71 here. And I'll do my normal CDF. My lower bound, which is 60, upper bound, which is 71, our mean, which is 70, and then our standard deviation divided by the square root of n. And we got 20 test grades, so I put 20 in there. Let's see what that gives us. Second vars, normal CDF, and 60, comma, 71, comma 70, comma 2 divided by the square root of 20. and we get 0.9873. And let's do it by hand now. So we're going to have this formula we're going to use. Z is equal to x minus mu sub x bar over sigma sub x bar. Mu sub x bar is equal to mu, which is 70, and sigma sub x bar is equal to sigma divided by a square root of n, which is 2 divided by a square root of 20 in this problem. So 2 divided by the square root of, was it 20? So we get 0.44721 35955. And I'm going to store this because I'm going to use it in a couple places. So I press my store button, STO, and I push the X key, and then enter. So that's now stored in X. X might be an inappropriate place to store it since we're working with X values here, but I think you get the idea. You can actually store it in any of these green letters here, A, B, C, all those. You can store it in there. Okay, let's convert these. So I'm going to have Z is equal to 60 minus 70 over 0.44721 35955. And this one will be 71 minus 70 over 0.44721 35955. I think you've seen enough of these. I'll shorten it a little bit. So this is negative 10 divided by x. Well, it gets worse and worse. So this one is negative 22.36. 71 minus 70 up on top is 1. So got 1 divided by x. And this one is 2.24. So our picture, and these are in terms of z-scores. We got negative 22.36 and 2.24. Shading it like that. Have to rewrite it for our tables in the back. So I do 2.24 first minus negative 22.36. Now I remember this from the previous problem. Our smallest value on our table was this, so I know that's going to be that. But let's go look up 2.24. Of course, the 4 is in the hundreds place, so I'm going to look in this column. 2.2, here's 2.2. Oh, my eyes are getting off. 0.9875, assuming my eyes didn't get off. And subtract that, and we get 0.9873. Ha! Matches perfectly. What do you know? I guess sometimes the rounding works to your favor. So let me save that. And let's take a look at our top or last one here. We got 5, and then given 30 test scores with a sample mean of 80 and a standard deviation of 5, the value that separates the top 10%, and I've shortened this quite a bit. When I say top 10%, then this is 0.9 90. And we're trying to find this value here. So we're wondering what that is. Well, if we do this via the calculator, we're going to do I and V norm, the area of the left, which is 0.90, our mean, which is 80, and a standard deviation of 5. So we're going to take 5 divided by the square root of 30. So a sample mean of that and a standard deviation of this. So let's see what that gives us. Second bars, I and V norm, 0.90. Brain shutting down. 0.90, comma, go eat some egg rolls, that'll revive me. 80, comma, 5 divided by square root of, what was it, 30? Yeah, enter. And I'll take it 2 decimal places, 81.17. So it's kind of the same as we did with I and V norm before, except for our standard deviation is the standard deviation divided by square root of n. Okay, now let's look at it by hand. Well, if they give us this, that's 10%, this is 90%, and we're trying to find this value right here, we're going to go look it up on our table. Hopefully I remember how to do this by hand. I've done this so much with the calculator that I sometimes forget the by hand. 0.90. Here's 0.9015. Here's 0.8997. That's probably closest. 0.8997. I go over to here. That's 1.2, and I go up, and that's 8. So that's 1.28. Now z is equal to x minus mu sub x bar over sigma sub x bar, and sigma sub, or mu sub x bar is equal to mu, which we said was 80. Sigma sub x bar is equal to sigma divided by the square root of n. And scrolled up too soon. We said that was 5 divided by the square root of 30. Let's see what that gives us. Five divided by second x squared, 30, enter, and a bunch of decimal places. 0.91287, 09, 292. Now I'm going to store that off because I don't want to keep entering that. So I'm going to press my store button, and I'll put it in, let me put it in S for sigma. Now S is above the ln, so if I do alpha ln, it'll put S on there. Enter. Okay, that's now an S. So we found our z-score, that's 1.28. X is what we're trying to find, minus mu sub x bar, which is 80, over this mess, 9128709292. Now we're going to multiply both sides by that. So I got 1.28 times 0.9128709292 equals x minus 80. Try and get x by itself, so we'll take negative 80 over the left side, and we get 80 plus 1.28 times 0.9128709292, assuming I didn't drop any decimals, equals x. Now let's put that in our calculator. We got 80 plus 1.28 28 times this number. That number we stored off in S. So I'll do alpha ln to get the S back, enter. And 2 decimal places, and I get 81.17 for X. And it matches exactly. I'm surprised. Well, did we do any kind of rounding? Actually, I didn't do any kind of rounding at all, did I? But, and this was exact. Well, no, it wasn't exact. It was a little bit off. Oh well. At least you can't predict when it's going to be a little bit off and when it's not. And let me save that. And stop the recording. And stop the other recorder.